Hello guys, I am here to explain lead code question number 1743, restore the array from adjacent pairs. So in this question we have been given an integer array nums which has n unique elements, and we have forgotten that array, but we have the every pair of the adjacent element in that nums. For example, in this question we are given 2 comma 1, 3 comma 4 and 3 comma 2, which means in that array which we have forgotten, 2 and 1 are together, are adjacent, 3 and 4 are adjacent, and 3 and 2 are adjacent. So the resulting array is 1 comma 2 comma 3 comma 4. So as you can see, 1 and 2 are here, okay, 3 and 4 are here, and 3 and 2 are here. And we have to find the original array which was there. So how can we find? So how can we find the original array? Okay, first of all, what we can try to do is we can try to make some graph out of all these pairs, and let's try to connect these elements together. Let's try. 2 is connected to 1, and 3 is connected to 4, and 3 is connected to 2, and in this way. So as you can see, this makes a chain, and our answer is also going to be in any order of the chain. So in example 1, the answer is 1 2 3 4. So as you can see, the answer is going to the chain like this. So the answer will be this. Okay, same goes for example number 2. Let's make the graph for example number 2. 4 is connected to -2, okay, 1 is connected to 4, okay, and -3 is connected to 1. So this is our -3 and it's connected to 1. Okay, so again we got a chain which goes like -2 4 1 -3, -2 -2 4 1 -3, in this way. So we can find the answer in this way. Okay, but how to implement this? So what we can do is, first let's make the graph for example number 1. Okay, just for the simplicity's sake, and these are connected like these. Okay, now what we can do is we can make the graph and then find the in degree of every element. In degree means that number of connections that node has. For example, 2 has 2 connections, one is to 1 and the other is to 3. But our goal for doing this is because we need to find the corner, we need to find the initial number for this, right, which will be 1 or 4, right? Because we are going to start from either 1 or either 4. Both of these are correct, so we have to start either from 1 or 4. So we have to find that number which from which the chain actually starts. Okay, so we will find the in degree for each number. It's either gonna be 2 or 1. So we can choose any element which has an in degree of 1. Okay, so it can be 1 or 4. Then once we find that number, we will just start traversing from that number to other, and just systematically find our answer. This can be the approach. Okay, so let's try to implement this first. Okay, we are gonna make a graph. We are gonna make a graph first. Let's make okay, this is going to be our graph. Now let's create, this will be an adjacency list. It's of this form. Okay, let's make that form. 2 for 2 there will be 1 comma 3, and then for 3 there will be 4 comma 2. Okay, and then for 4 this it will have 3 only, because 4 is only connected to 3, and for 1 we will only and only have 2, because 1 is only connected to 2. Okay, so this will be our adjacency list. We will make this. Let's make it. We are connecting this node to, we are connecting 2 to 1, and then we are connecting 1 to 2, like see 2 is connected to 1 and then 1 is connected to 2. So we are going to do that. Okay. Oops, it's one here, 0 and 1. We connected a0 to a1 and then a1 to a0. Okay, well and good. Now we will find the start of this graph. Okay, let's declare a variable start and the size of the vector. Okay, how? Now we need to think. Okay, if there is a graph like this, okay, like 2 1 3 4, and all these are connections. Okay, like 2 can this and this. So as you can see, number of edges are number of elements minus 1. Okay, which means that the size of the array will be number of edges plus 1, which means adjacent pairs dot size, which means the n, which will be the size of the array, will be adjacent pairs dot size plus 1. Okay, and let's declare the vector also, which will be initially empty. Now let's start with adding elements to this vector. Okay, also we need to keep track of how many elements we have visited, because we don't want to visit any element again. Like if we are going like this, if I am going like this, and then I again go to 1, it's not a correct thing. What we want to go do is we first arrive at 1, mark it as visited. Okay, and then we are here at 2, and then at 2 we are gonna check if any element is not visited, then I will go to that element. So from 2 I will mark it as visited, and then go to 3 instead of 1, because 1 is already visited. Same goes for 3, we check for 2, it is visited. Okay, so I'll not go there, I'll go to 4. Okay, and then I end at 4. Okay, let's begin. Okay, we are going to do this while our answer has a size of what we require. So is less than n. First we will store the start. First we will store the current node, which will be start. Okay, we will store it into answer. But before that we have to find the start itself. So how are we going to find the start? Okay, we will traverse through this graph and then check. We have already discussed this. We will traverse through the graph and then find which of these elements has only one other connection. That can be our start. Like we go to 2, no, it has 2. For 3 it has 2, 4 and 2, and here at 4 it has only 1, 3. So 4 can be a start, as well as 1 can be a start to our traversal. Let's do that. If I dot second dot size, if the size of this vector is 1, that can be our start, and then we'll break out of the loop. Cool I dot first. Very cool. Okay, so we have done this. Start is done. Okay, now we will just move through the graph and just keep on marking the elements as visited. Okay, so that can be stored in an unordered set. Okay, let's push dot push. Oops. And then we'll mark this as visited. Okay, now we will go through all the elements there for that start. If any of the adjacent elements to this element is not visited, then only we are gonna go to that. Okay, if not visited dot count I, then only we will go to that node. So what will be happening? Start will become is equal to I. Okay, so this loop will occur for the entire t. Okay, and in the end we simply return our answer. Let's check. Yes, the sample test cases are all getting accepted. Let's just submit this code. Yep, it got accepted. Now what's the time complexity for this? Okay, now time complexity is going to be linear because we have just made a graph. I have just made a simple graph and I am traversing that. So 2 1 3 4, like this is just connected. Okay, nothing special. Like these are connected. First traversal is linear. Okay, this is linear complexity. Okay, here also it's linear complexity. Okay, this is also going to be linear because we are just moving through the elements one by one. For 1, then I go to 2, then here from 2 I will go to 3, and from 3 and then I will go to 4. So it's also big of n, so the time complexity will be big of n, linear. Now speaking of space complexity, we are using graph. Okay, so that's linear, like 2 1 comma 3. For 3 it's 1 comma 4 comma 2, 1 for 1 it's 2, and 4 it's 3. So our graph also takes linear time complexity. Okay, also we are using this array answer which takes linear complexity. This unordered set takes linear complexity. So our answer is linear time complexity and linear space complexity. Okay, so I hope you like this approach. Thank you for watching and see you with the next one. Bye.